Hello, this is part 2 of preparing for the test tomorrow, test number 7, which will cover some AP type material and some integrals and derivatives. I asked you to look at this one from class, and hopefully there's a little more on the page than when I saw it last. I asked you to go ahead and look at this. It's the function g prime, so it's the derivative of a function. And I asked you to find where g is increasing and concave down. So if you would try that before you look at my answer, so you'll have good practice for tomorrow. Remember, this is the derivative you're looking at. This is what the derivative's doing. And I want to, first of all, graph the function. There's no way to answer this question without doing that. All right, so pause and do your magic. All right, coming back, let's see where we are here. Let's go ahead and graph this function and see if I can pan out a little so you can see the function and the graph of the derivative at the same time. All right, I can see down here somewhere at x equals -4, I don't know where, I'm going to start graphing my function. That function is, at the very beginning, you'll see the value is negative. I can tell by looking at the value of this function and reading it over here. It's definitely below the x-axis, and on the y-axis, that's where the negative values are. So I'm going to start somewhere. I just pick a place at x equals 4, and I'm going to give it a negative slope, becoming less and less negative, and then actually the slope is 0 very quickly at -3. So I'm going to have a valley there. So I'm going to mark that as an important point. And then, see if I get some more light in here. No, having trouble with my lighting here. Okay. Let's see how it shows up. And now I am going to observe that the function's derivative is positive for a long time until it peaks at 4. So I'm going to draw a function that is, first the slope isn't great, but then it becomes quite steep. And at the steepest point, at x equals 0, we have a slope that's very steep at 4. And then you'll see that the slope starts decreasing, yet it's still positive. So we talked about today that it'll start a little wobble there. It still has a positive slope, but at that point the slope becomes less. It was like gaining slope, and now it's not. So it creates an inflection there. So we talked about whenever the derivative is changing directions, it creates this sort of situation. So then the slope is going to decrease and decrease until it hits 3, where it zeroes out. And so that's a mountaintop. And then it becomes negative, so I have to turn around and have a negative slope from there on. So hopefully your graph looks something like this. So we have a function that has a local minimum here, an inflection here, and a local max here. All right, and the question didn't have anything to do with that. It says find where g is increasing and concave downward. So it's going to be concave downward when it's frowning, and increasing means it's moving in the upward direction. So we're looking for a place where that's happening. So here's a smile, so I'm looking for a frown, and it starts frowning right here. And at this point, look at that. It is increasing and it's frowning. So that is the area that answers that question. And then it's still frowning, but it's decreasing. So what I'm looking for is this area right here, which I believe is between 0 and 3. Actually, on your paper, it might be a little different than that, but whatever your paper says, mine is a rough sketch of what your paper said. So that is how you do part one. I mean, that's how you do the part one of this problem. All right, I'm going to actually shut this video down because the first attempt, several attempts at loading this didn't take. So I'm going to make a short video of one problem and then a short video of another. So this will be part two of your review, and then there'll be a part three, just to see if it uploads a little better with shorter versions. So I'm going to take a time out here, and I'll be right back with you when you pull up the next video.